Page 1 of quadratics. Of course, they start with a review of factoring, but like I told you, if you still don't know how to factor at this point, I don't think now is the time to learn. Why don't you just rely on quadratic formula? There's not going to be that many factoring problems on the IB exam anyway. Now, if you want to learn factoring for some other reason, like for the non-calculator portion of the SAT or future math, please go right ahead, watch this video, do your best, but there's no use learning factoring for the next exam because you don't need it, okay? So if you're learning factoring now, learn it for the long term, make sure you're learning it forever, do enough problems of practice, or just don't do them. So 1A, this is a really easy factoring one. Do you see how it only has 2 terms instead of 3? And what is the common factor between these two? Looks like it's x, right? There's an x in both. So if I factor out an x out of 4x squared, I get x parentheses 4x. And then if I factor out an x from the 7x, I get 7. So I get x times 4x plus 7. Now they want us to solve the equation, and if these two together are multiplied by 0, we're going to use the null factor law, which is that if two things multiplied together are equal to 0, then either the first thing has to be 0 or the second thing has to be 0, not necessarily both, okay? Now, in this particular case, if I say that the first thing is 0, basically what I'm doing is I'm saying that the solution is x equals 0. If I say the second thing is 0, then that's a little bit harder. It's some kind of fraction, so I'm just going to write it all out. 4x plus 7 equals 0 is what we believe, and then we're going to isolate x by itself. So first thing we're going to do is we're going to subtract 7 from both sides. On the left side will be 4x, right side will be negative 7, and then we're going to divide 4 from both sides, and then the left side will be x, and the right side will be negative 7/4. So that would be the other possible solution. So the first solution was x equals 0, and the second possible solution is x equals negative 7/4. So you could write the solution is x equals 0 or negative 7/4, but not both, obviously, because they're not even the same. Okay. All right. Let's move on to E. 3x squared equals 8x. Okay. Now your instinct might be to immediately divide both sides by x and eliminate an x, but be careful when you do this, because sometimes when you do that you'll lose one of the solutions. Okay. So first thing you're going to do is you're going to make this into a quadratic too. Obviously there's only 2 terms, so it's going to be kind of a short quadratic. I'm going to subtract 8x from both sides, and then I'll get 3x squared minus 8x equals 0. So obviously the c term is 0. And now I can factor out an x. So I get factor out an x, and I end up with 3x minus 8 as the other factor. Now this factor here, obviously the solution to make that 0 would be x equals 0. This one here is a little bit more tricky, so we're going to write it out. 3x minus 8 equals 0. We're going to try to isolate the x, so we're going to add x to both sides, so we get 3x equals positive 8. Then we divide both sides by 3, so we get x equals 8/3. So one of our solutions is x equals 0, and the other solution is or x equals 8/3. Let's do number C, or letter C. So for this one, it's already all on the left side. We don't need to collect our terms on the left side. Let's factor out an x out of each, right? Because it's only got 2 terms, and both have x as one of the factors. So we end up with this. And this term x gives us the solution x equals 0. 3x minus 7, that will a little bit more complicated. We'll set that equal to 0. And then we will isolate the x by adding 7 to both sides. And then we'll divide both sides by 3. So we get x equals 7/3. So that's one of the solutions, and this is the other solution. G. So we have here a full-fledged quadratic with 3 terms. Now, I'm going to show you one way to do this one, and then on the next one we'll try to show you a new way to do it. Maybe the other way will appeal to you, okay? Okay, so if you're still watching, that means you still want to learn how to factor after all these years. I'm going to repeat the method that you probably learned sometime between 6th and 8th grade, and then after that I'm going to show you a different method which is a little bit more powerful, and maybe this will do the trick, and maybe you'll remember how to do this way as opposed to the original way. So let me show you first the way that typically people learn at the beginning, and that is when I look at this, I see that the a value is 1, and so that means that this is going to be relatively easy to factor. The way I factor it is I write every single possible pair of factors for positive 6, and then I choose which one of those adds up to give me negative 5. And you don't actually do this in real life. You don't actually write down every single pair. But you do this in your brain, though. You do this mentally. So 1 times 6, negative 1 times negative 6, 2 times 3, negative 2 times negative 3. These are all factor pairs which can multiply together and become positive 6, right? Now, which of these, when you add them together, becomes negative 5? Well, that's easy. This one. You know, this is like not so hard as long as you list every single factor pair. The problem is, like, sometimes you get like some number like 144 or something where there's like so many different factor pairs that you want to take shortcuts, and then it's not so easy, right? So I know that I can put x minus 2, x minus 3 as my two binomials. And now if I test it, I can do FOIL, and I'll see that the first term is indeed x squared. The last term is indeed positive 6. And then if I do the inside term, it is negative 2x, and the outside term is negative 3x. If I add those together, I do get the middle term of negative 5x, so everything's fine, right? So now I say, okay, what are the solutions to this? The solutions we can find by setting each individual binomial to 0 separately. And so x can equal 2 or x can equal 3. Those are the two possible solutions, okay? So that is the way that you already know how to factor. It's just sometimes you forget how to do it, right? Let me show you some other ways to do, another way to do factoring, and I don't know if this is going to be, it's definitely, I don't think, it's not quicker, but you know, maybe it's like more methodical with less trial and error, because usually you don't write this whole list. Usually you just try numbers until you get it. You get kind of an instinct for which ones are going to work. So first thing I'm going to do is, they didn't give us a quadratic with everything on the left and 0 on the right, so I rearrange it by subtracting 12 from both sides, right? Next thing I'm going to do is I'm going to take my a value and my c value, and I'm going to multiply them together, and I get the number negative 12. Then what I do is I try to see if I can break negative 12 up into two numbers which will add together and give me positive 1. Okay? So for example, negative 13 and positive 1. Negative the first part of it, the first part of this other method is kind of the same. It's just the end that's different. It's called factoring by grouping. And the first thing that we need to do is also the same. We need to get everything on the left side and put 0 on the right side. We just subtract 12 from both sides, so we get it in that form. Okay. And then the next part is similar. We're going to write down, and this could be mental, you're going to write down every single possible pair of factors that give negative 12, integer factors, of course, and then you're going to go through to see which one fits. Okay, and if you look at all the pairs of integer factors, one of them gives us plus 1 when we add them together, and that is this one. Right? Negative 3 and positive 4. And the last step, which is a little bit different than the other step we did, is we're going to break this up into negative 3x and positive 4x, because those add up together to get 1x, right? And we're going to put them right in the middle of our quadratic. Instead of 1x, we're going to replace them with the two factors which add up to 1x. Now we're going to do a test. We're going to see if the proportion between 1, negative 3 is the same proportion as 4, negative 12. And if it is, and in this case it is, right, I can multiply 1 times negative 3, I get negative 3. I can multiply 4 times negative 3, and I get negative 12. So they are proportional, so we're fine. So that's just a double check that we indeed chose the right pair here. And now all we need to do is we need to factor out the greatest common factor out of each one of these binomials that are added together. And we're going to factor out an x out of the first one. And once we do that, you're going to see why this is maybe so cool. Then we factor out a 4 out of each one of these. And now you're like, oh, wait a second, there's an x minus 3 in both. Now we can factor an x minus 3 out of both. And then we end up with that, and that's equal to 0. So what we know now is that either one of these factors has to be 0 for the equation to be true. So either x minus 3 equals 0, in which case x equals 3, or x plus 4 equals 0, in which case x equals negative 4. So both of these, or one of these, has to be true. Of course, they're not going to be both true at the same time because x can't be 3 and negative 4 at the same time. So it's or, right? All right, let's do one more, okay? So first thing, we need to get everything on the left side because you can't factor unless the right side is 0. So I'm going to subtract 10x from both sides. And then now what I'm going to do is I'm going to write all the factors of positive 21, which would be 1, 21, negative 1, negative 21, 3, 7, or negative 3, negative 7. Okay, those are the 4 pairs. And now I need to figure out which one of these pairs adds up to negative 10. Well, that's pretty easy, right? It's this one. Okay, so now what we're going to do is we're going to replace the negative 10x with negative 3x and negative 7x. Okay, so we'll do x squared minus 3x minus 7x plus 21 equals 0. Okay, now what we're going to do is we're going to divide this up into two binomials added together, and we're going to factor out the greatest common factor out of each. So the greatest common factor of x squared minus 3x is x. So I'm going to factor out x. So I'm going to get x times x minus 3. And then for the next two factors, which are negative 7x and positive 21, the greatest common factor is negative 7. So I end up with x remaining in the first term. And if I factor out a negative 7 from positive 21, I end up with a negative 3 here. And now I see that there is a factor of x minus 7 and x minus 3 in each term, so I'm going to factor out x minus 3, and I get x minus 7 remaining. So now the two possibilities are that x minus 3 is equal to 0, or that x minus 7 is equal to 0. So if x minus 3 is equal to 0, x is actually equal to 3. And if x minus 7 equals 0, x is equal to 7. Okay, so x equals 3 or x equals 7. 2a. We're going to now apply the same procedure to the problems where a is greater than 1. And these are pretty challenging problems when you do it using the same method that we originally did without factoring by grouping. So maybe you'll see the advantage to using factoring by grouping this time. Okay? The difference between now and last time is, the first thing we're going to do is we're not going to list the factors of 4, we're going to list the factors of 9 times 4. So 9 times 4 gives us 36, right? So 36, it gives us positive 36. So the factors for positive 36 are 1 and 36 and their negatives, 2 and 18 and their negatives. When I say their negatives, I mean negative 2 paired with negative 18. 3 and 12, 4 and 9, and 6 and 6, okay? And their negative pairs, right? And now we look and say, okay, which one of these pairs, when added together, gives us negative 12? And we can see that negative 6 paired with negative 6 gives us negative 12. Okay, so let's go ahead and substitute negative 12x with negative 6x, negative 6x, and see what we get. Negative 6x, negative 6x plus 4. Now we can double check to make sure that the ratio 9 to negative 6, which is 3 over negative 2 basically, is the same ratio as negative 6 over 4, which is negative 3 over 2, basically. So yeah, they are identical ratios. So that's a good sign. Now we're going to factor out the greatest common factor out of each binomial added together. And so the first thing is we're going to factor out, I think, a 3x. Is that right? So then we have a 3x remaining, and then we have a negative 2 here. And then for the next one, if I factor out a common factor of 2, negative 2, I would get 3x remaining out of the negative 6x, and if I factor a negative 2 out of a positive 4, I end up with negative 2. And then I can see that, oh, if I factor out now a 3x minus 2 out of each term, I end up with 3x minus 2 times 3x minus 2. Two identical factors. And then I just need to check one of the factors then to see what x value makes that 0. It would be x equals 2/3. That would be the solution. Okay? Let's move on to E. So first step, again, we need to put this on the left side because we want 0 by itself on the right side. 5x plus 3 equals 0. Then we say, okay, we're going to multiply together 2 and 3, the A and the C value, and we're going to get 6. And then we're going to say, okay, what are the possible factors of 6? They are 1 and 6, and they're negatives. Negative 1, negative 6, for example. They are 2 and 3, and they're negatives, and I think that's it. So which one of these pairs adds up to negative 5? It would be negative 2, negative 3, right? So this is our what we're going to use to break down the negative 5x. So we'll have 2x squared minus 2x minus 3x plus 3 equals 0. Then we're going to group these two together, and we're going to factor out the greatest common factor. So we get 2x times x minus 1. Yeah. And then we factor out a 3, a negative 3 out of the next two, and we end up with an x. And then when we factor a negative 3 out of positive 3, we end up with minus 1. And then we factor out x minus 1. So if we factor out x minus 1, we end up with 2x minus 3 as the other factor. And so and we set that equal to 0. So x minus 1 equals 0. That means x is equal to 1. 2x minus 3 equals 0. That's 2x equals positive 3. X equals 3 halves. So the two solutions are x equals 3 halves or x equals 1. Okay, and so that we've kind of taken all the guessing out of factoring by doing this method. Okay. Now, again, we need to move these to the left because we want everything on the left side, and we just want 0 on the right side. So it would be minus 12x, or minus 16x, plus, or minus 12, okay, equals 0. Now we multiply together our A value and our C value, which gives us negative 36. So the factors that multiply together and give you negative 36 are 1 and negative 36, or vice versa. 2 and negative 18, or vice versa. 3 and negative 12, vice versa. When I say vice versa, I mean negative 3 and positive 12. 4 and negative 9, or vice versa. 6 and negative 6, or vice versa. Well, 6 and negative 6, vice versa, that is the same thing. Okay, so which one of these added together gives us negative 16? Looks like this one might. Okay, 2 minus 18, that gives us negative 16, right? So let's do that. We're going to put 3x squared, and we're going to put plus 2x, and then minus 18x minus 12 equals 0. Okay, let's try to do group factoring by grouping here. So what is the GCF here? It would be x, so we end up with 3x plus 2. And then what's the GCF in the second pair? It would be negative 6 or something like that. So negative 6, and then what do we have here? Factor negative 6 out of negative 18x, and you get 3x. Factor negative 6 out of negative 12, and you get plus 2. And then you're like, okay, that looks good. These are common factors. Now we can factor that out, 3x plus 2. And then what's remaining is x minus 6, and we're almost done. Now we can see that 3x plus 2 equals 0, this gives us 3x equals negative 2, x equals negative 2/3, so that's one solution. This here, the solution is x equals 6, right? So the solutions are x equals 6 or x equals negative 2/3. Okay, let's move on to the last row of problems. First step, once again, is to put everything on the left side. So subtract 10x from both sides, subtract 8 from both sides, and we end up with equals 0 on the right side. Then we multiply together 3 and 8, which gives us negative 24. And then we figure out all the factor pairs, which give us negative 24, which are 1, negative 24, and vice versa. 2 and negative 12, vice versa. 3, negative 8, vice versa. 4, negative 6, vice versa. And that's it, right? Okay. Now we're going to see which one of these can you add together and get negative 10. Looks like it would be this one, right? 2 minus 12 is negative 10. So we can replace negative 10x with 2x and negative 12x. So 3x squared plus 2x minus 12x minus 8 equals 0. Now we're going to group these, do factoring by grouping. What is the greatest common factor between 3x squared plus 2x? Just x. What is the greatest common factor between negative 12x and minus 8? It's just negative 4. Okay, so let me factor out 3x plus 2 from each term. I get 3x plus 2, x minus 4 equals 0. And then I can set each one of these equal to 0. And my solutions are x equals negative 2/3 and x equals 4. Okay. All right, let's do k. So again, first step, put everything on the left side. Second step, multiply together a and c, and we get negative 7. The possible pairs, factor pairs for negative 7 are 1 and negative 7. Can you hear the dogs barking? Can you believe it? They let dogs into the American hotels now. You can't smoke, but you can have dogs. Not that I want to smoke or have a dog in a hotel. Okay, so you're going to take 1 and negative 7, and you're going to see if those could add up to become positive 6. Well, not 1 negative 7, but the vice versa can, right? 7 and negative 1 could. So we're going to break up the positive 6 into positive 7x and negative 1x. Okay, and then we can group these, and like 7x squared plus 7x, the greatest common factor is 7x, right? So that would be x plus 1. And then the greatest common factor between negative x minus 1 is equal to minus, it's just negative 1. So then I end up with x plus 1 here. And then I factor out the x plus 1, and I end up with 7x minus 1. So my two factors are going to be x equals negative 1 and 7x minus 1. That's a little bit too much thinking to do without writing it down. So 7x minus 1 equals 0, 7x equals 1, x equals 1/7. Okay, so my two solutions are x equals 1/7 and x equals negative 1. Last one. Again, first step, move everything to the left side. Set the right side equal to 0. And then we're going to multiply together 4 and negative 3, and we get negative 12. What are the possible factors when you have negative 12 as your a times c? It would be 1 and negative 12, or vice versa. 2 and negative 6, vice versa. 3, negative 4, and vice versa. Do any of those add up together to get negative 11? This one does. So we can replace the negative 11x with that. We could replace it with plus 1x minus 12x minus 3 equals 0. Now we can do these pairs here, and we can factor out the GCF. So the first GCF is going to be x, and what we're left with inside is 4x plus 1. And then the next one, we're going to factor out negative 3, and what we're left with inside is 4x plus 1. Then we factor out 4x plus 1 out of both. And then we end up with x minus 3 remaining. And so now we can figure out our solutions. 4x plus 1 equals 0. 4x equals negative 1. X equals negative 1/4. X minus 3 equals 0. X equals 3 is the other solution. So we're done. The solutions are x equals negative 1/4 or x equals 3. And that's it for page 1.